This is part 1 of lesson 12.3, and today's lesson is on box and whisker plots. First of all, this is what a box and whisker plot looks like. And so it's named that because obviously it has a box and it has these little pieces going out that look kind of like whiskers. So that's why it's called a box and whisker plot. It's a number line is given so that you can tell where the numbers match up. So we're going to talk a lot more about that. But let's get some vocabulary as far as the different parts of the box and whisker plots. So a box and whisker plot is a graphic way to display median, quartiles, and extremes. It does not show any other information. So things like mode or mean does not show in a box and whisker plot. So a box and whisker plot is good if you're looking for middles or medians or highs and lows. There are 5 data points that are represented in a box and whisker plot. The first one is the minimum or the lower extreme, and so that's the smallest data point. And so I'm going to put number 1 right there. Actually, no, I'll put minimum right there. So label your box and whisker plot. That's going to be minimum. And then the next one, maximum or upper extreme, and that's going to be the highest number that you have. Now the quartiles, if you look at those, so the prefix quart means a fourth. So like a quarter is a fourth of a dollar, a quart is a fourth of a gallon. So when we say lower quartile, we're talking about the first fourth of the data. And so like this part of it. So when we say what is the first quartile, it's going to be the number that's right here. So that's going to be quartile 1. So if I say what is quartile 1, in this one it looks to be about 72. Now quartile 2, we also know that one as the median. So the median, I'm going to put median right here, but then I'll also put quartile 2. We usually just say we just usually say median. We don't say quartile 2. And that's going to be the middle of the data. So you've got half the data on one side, half the data on the other side, and that's what the median is. The upper quartile or quartile 3, that's going to be the median of the upper half of the data. So this is your upper half, and then this is the median of that upper half. So that's what quartile 3 is. So we don't say we have a quartile 4, so it's just 1, 2, and 3. We have something new called the Interquartile Range, and we abbreviate that as IQR. And what that is, instead of just being a regular range, which is the maximum minus the minimum, it's going to be the interquartile range. So from the one end of the box to the other end of the box. So in this particular picture, it looks like it'd be like 90 minus 72. And so that's what the interquartile range is. So that's another way to tell like how spread apart things are, but it's not the entire picture like the range is. Okay, we're going to talk about outliers, and we're going to have just kind of a very limited discussion about outliers because outliers are kind of a different, difficult thing to talk about. But outliers is a data point that's significantly different than everything else. So for example, if I gave a test and everybody got like 80, 90, 100%, and then I had one person that got a 10%, that would be an outlier because that's so significantly different than everybody else. Now, if everybody got 80, 90, 100, and then I had somebody that got like a 65, that's not really as significant. And so with an outlier, it's just different and it's going to change how everything looks. And so there are certain ways to determine like what is significant. So there's a way to determine the outlier. We're not really going to do this. I think we've got one example where we'll talk about it, but it's not really something that we're going to concentrate on. What we are going to talk about is in a box and whisker plot, if there's an outlier, we represent that with an asterisk somewhere. You still count the outlier when you're doing the maximum and minimum. You still count it when you're doing the median and the mode and the range and all of that. So we'll do some examples with that. When you do AP stats, if you do that, or college level statistics, you'll talk a lot more about outliers. But that's not going to be a point of concentration in this class. Okay, we have 2 types of measures that we use. And so one is the measure of central tendency, and that's what we've been using. And that's the mean, median, or mode. These are different types of averages. Now, usually when we say average, we're talking about the mean. But a median is a type of average and a mode is a type of average. And so they all tell us kind of the big picture of what's happening with our data. There's the second kind of thing, the measure that we have, and that's measures of variation. So we haven't talked about that as much. So we've talked about the range before, and that's like how widespread everything is, what kind of variety there are to the data. The interquartile range, that's kind of a smaller area. So when we talked about like the box and whisker plot, the interquartile range is just that much. So how spread apart is that much of it? So that's kind of talking about just the middle percent, or the middle part. And then the other one we're going to just start talking about today is standard deviation, then we'll go into that more in the next lesson. But those are measures of variation. So when we say measures of central tendency, we're talking about mean, median, and mode. When we talk about measures of variation, we're talking about range, interquartile range, standard deviation. This tells us about the averages, and this tells us about the variety. And that's kind of a way you can remember it. How widespread is everything? Does it change a lot? That kind of thing. So let's go to box and whisker plots, and we're going to start by reading a box and whisker plot and seeing what it says. So it says the box and whisker plot below represents the points students earned on a term project. Each section of the box and whisker plot represents 25%. Remember, quartile, it's a fourth. And so this is 25%, 25%. Remember that they don't have to be the same, because you could have 25% of students fit in a very small range, and then you could have another 25% of the students that are more widespread. So your box and whisker plot may not be symmetric, and that's okay. It still divides it into 4 different parts, and it's 25%. So if I look at my box and whisker plot, what is the min? So this right here, that number right there is going to be my minimum. So that's the lowest score anybody got on the box or on the project. What is the max? That's going to be 350. So nobody got higher than 350. What is the median? So the median, remember, is this line that's in the box. It doesn't have to be in the center. It may not be in the center, but it is in the center of the data. So that's going to be 200. That's my quartile 2, same thing as quartile 2, but we usually just call it a median. Okay, what is the first quartile? Now, people get confused about this sometimes, and they think, like, is it here? Is it here? Is it from here to here? And so when you're talking about the first quartile, the number you're going to use for that is this edge of the box right there. So that's going to be 150. Now, what that means is it means 25% of the class scored between 50 and 150. That's a fourth of the class, and so that's what that is telling us. Okay, next, what is the third quartile? The third quartile is going to be the upper end of the box, so that's 300. And so if you think about like the 25%, we've got 75% of the students scoring between 50 and 300. Only 25% of the students scored above 300. And so those are things that we can tell from the box and whisker plot. Okay, what is the interquartile range? You're going to take the top end of the box, subtract the bottom end of the box, and you're going to get 150. That's the interquartile range. Now, the next few questions are about the percentages. And so when we're talking about box and whisker plots, the only percents we can ask you about are 25, 50, 75, 100%. We cannot ask you about 30% of the data or 85% of the data. We can only ask you about the 25, 50, 75, 100. So it says what percent of data is between 50 and 300? So between 50, which is right here, and 300, that's 25, 25, 25, so that's going to be 75% of the data. So 75% of the students. What percent of the data is between 200 and 300? So 200 to 300, that's going to be 25% of the students. What percent of the data is between 500 and 200? Or sorry, not 500, 50 and 200. So if we look at between 50 and 200, that's going to be 50%. What percent of data is between 50 and 350? So from 50 to 350, that's 100%. Everybody's included within that range. Okay, the next thing, it says if 80 students are represented in the box and whisker plot. See, looking at the box and whisker plot, just that by itself, I do not know how many students we're talking about. It could be 50, it could be 3,000, I don't know. In question number 11, it says, okay, so let's say this is 80 students. So that's what we're talking about, 80 students. So if that's the case, how many students got between 300 and 350? We're not asking for what percent got between 300 and 350. I already know that. But how many students is that? So since that's 25%, 25% of 80 students got between 300 and 350. So you can just do the math. That's a fourth of 80. So that means that 20 students scored between 300 and 350 on this project. Number 12, if 80 students are represented in the box and whisker plot, how many students earned between 150 and 350? So between 150 and 350, we're talking about 75% of the students, so 75% of 80. And so you can just do the math there. And so it's 20, 20, 20, so 60 students. So if you're told how many people are represented in a box and whisker plot, then you can find a little bit more information. But if we don't tell you how many students we're talking about or how many data points we're talking about, some of the information is not something you could find. There are some things you cannot tell from a box and whisker plot. I mentioned this earlier. In a box and whisker plot, you cannot tell what the mean is because I don't know how many people we're talking about. I don't know their specific scores. These people got between 200 and 300. Did they all get 250? Did they get 201, 205? We don't know. And so we just don't have enough information to do that. We also can't tell, we can tell the median, but that doesn't mean anybody actually got that score. It just means that half the people got above and half the people got below. So there's just some things with box and whisker that we can't tell. So just be watching for that. Okay, let's make a box and whisker plot. So I've got these data points. The first thing you're going to do with these points of data is you need to put them in order from least to greatest. So let's rearrange them. So I'm going to put them in order from least to greatest. You want to make sure you don't skip any. And so I like to cross them off as I put them down so that I make sure I don't skip any. That's happened to me before. And I'm going to count and just make sure that I got all of them. So I'm counting that I have 10 data points. So I'm going to count up here. I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so I'm good. All right, so now what you're going to do to make your box and whisker plot, we're going to start with a number line. And so I'm going from 1 to 12. So you can start with 0 if you want to, but I really only have to start with 1. And I need to end with 12. So I'm just going to try to equally space it here. So I'm going to say 2, 3, 4, 5. So you can do that. All right, so you want to label your number lines so it's readable. You don't necessarily have to label every single point, but you want it to be readable. Okay, now the next thing you're going to do is you're going to mark your extremes, your minimum and your maximum. So I see my minimum is 1, so I'm going to put a dot right there. And my maximum is 12. And then I'm going to find the median. So looking at all my numbers, I know I have 10 numbers, so I'm going to go 5 on that side and 5 on the other side. So my median is between the 4 and the 5. So I'm going to go to 4.5, and I'm going to put a line like that. Then I'm going to look at my lower half, those numbers, and I'm going to find the median of the lower half. So that would be 2. So I'm going to come over here to 2, and I'm going to make another vertical line. And then I'm going to go to my upper half, and I'm going to find the median of my upper half, which is 8. Make another line right there. The lines are creating your box part of the box and whisker plot. And then the whiskers are from the box to your extremes. And you want your box to be up above the number line, not on the number line. And that's your box and whisker plot. And so since mine is very readable and I can tell like this is, pretty easily see that that's 4.5, I'm not going to need to label it. So with that information, you should be able to answer all of the questions below 13 through 19. Number 19, I'm asking you about a comparison, so you're going to have to find one other piece of information before you can answer that question. So go ahead and pause, answer the questions. Let's just make sure you understand how to read that. Okay, number 13, it says, what is the median? That was 4.5. What is the lower extreme? That was 1. What is the upper extreme? That was 12. The lower quartile, that's going to be your 2. The upper quartile, that's your 8. So you notice that if you made your box and whisker plot, you already know the answer to these questions. It also means that if you're trying to make a box and whisker plot, those are the questions you need to answer. That's where you get your information. Now, what is the interquartile range? You're going to take your 8 and you're going to subtract 2 and you're going to get 6. So 6 is your answer, not 8 to 2 or 2 to 8, it's 6. Okay, so number 19, it says, how does the median compare to the mean? So I already know what the median is, it's 4.5. So I need to find the mean. So I'm going to go and find the mean of those numbers up there. Add them all together, divide by 10, and you will find out that your mean is 5.2. So as far as comparing them, since I don't have really any context to this problem, I can say the mean is higher than the median, or I can say the median is lower. If there's context to the problem, you can talk about it a little bit more. But for right now, we're just going to say the mean is higher. Okay, let's do one more. So I want you to do this box and whisker plot with this data, and then you're going to go back to this video and let's just make sure you got it all right and answer the questions, and then we'll continue. Okay, here's what you should have for your box and whisker plot. So you do have to put the numbers in order. So if you forgot to do that, then you've probably got it wrong. So you need to put them in order. And then you've got your max and your min, the 1.1 and the 1.9. You've got your first quartile, which comes out to be 1.2. So if you found the median, the 1.7, that's right in the middle. You've got 3 on either side. Look at the lower half. The 1.2 is the middle of that. Look at the upper half. The 1.8 is the middle. Because we had one middle number. On the last one, we didn't have a middle number. It was like between 2. So if you have a middle number, then you're just going to be looking at that side. You don't count the 1.7 when you're doing that. So that's how you get all of those numbers. The interquartile range is 1.8 minus 1.2, get 0.6. The mean comes out to be 1.6, and so that's less than the median. Not a lot less, it's a little bit less of 1.7, so I just put that it was less than the median. Okay, I've got some things arranged differently in the notes, and so I'm going to have you skip to actually 28, and then we'll continue at 28, and then we'll come back and get the other ones. Okay, so number 28, I've got 2 box and whisker plots on the same graph, and this is what you can do when you're comparing things. So I've got 2 classes, Class A and Class B, and I've got box and whisker plots for a test score. So one of the first things you might notice is that we have this. That's an outlier, okay, because that's significantly different. Again, we're not going to really go into the formulas for y and everything, but that's going to be represented as an asterisk on this box and whisker plot. So that means that this one student did a lot worse than everybody else. Everybody else was up there a lot higher. In Class A, we did have some people score below 52, but in that class it wasn't an outlier, so it wasn't so unusual for somebody to score 52 or 50 or somewhere around there, whereas in Class B, that was very unusual. So you notice that. Notice some things we don't know about the classes. We don't know which class is bigger. We don't know what the average score was. We do know the median score. So we do know that half the students scored below 79 in Class B and half the students scored below 70 in Class A. And then we know something about the upper half and things like that. But just keep in mind that there are some things we cannot tell from a box and whisker plot. So let's answer the questions. Number 28, it says in Class B, the upper 50% of the class scored above what number? So in Class B, upper 50% is above 79. In Class A, the upper 50% was above what? 70. So think about it, you had 50% of the class getting 79 or higher, whereas in Class A, you had 50% getting 70 or higher. So if you think about like what that looks like as far as which class did better, something to think about. Okay, number 30, what does the interquartile range of Class A represent? So the interquartile range of Class A is the difference between 78 and 65. And so that's going to be 13. And so that means that 50% of the students were within 13 points of each other, like in the middle. Okay, so we're going to say that the mid 50% were within 13 points. Now, if you compare that to Class B, their interquartile range was between the 72 and 83, and so that's 11 points. So they were more concentrated in that 50%, and so there wasn't as much variety in the scores. They weren't as different. It didn't go as widespread. And so that's what we're being able to tell from the interquartile range. Okay, so number 31, it says, which class appears to have an outlier? So it looks like Class B has an outlier. So, okay. And then it says, does it meet the definition? So let's go back to the beginning of the lesson. So at the first, it does say what the definition of an outlier is. Okay, so significantly different, but this is what significantly is. So it says the data point is greater than quartile 3 plus 1.5 times the interquartile range, or it's less than quartile 1 minus 1.5 times the interquartile range. So let's see if that applies here. So looking at Class B, okay, the quartile 1 is 72, and the interquartile range is 11. So if I take 1.5 times 11, I get 16.5. So my question is, does this satisfy that it is the quartile 1, 72, minus 16.5? Is it outside of that range? So 72 minus 16.5 is 55.5, and so it does meet the definition, like it is past that. So if I had somebody that got a 56, then that's not an outlier, but that kind of is where it's significantly different. And so it does meet the definition. So let's put down here that we're going to say quartile 1. What's quartile 1 minus 1.5 of the interquartile range? That does meet the definition of that. So I'm going to have 72 minus 16.5 is 55.5, and this is outside of that. Okay, explain what this possible outlier represents. So now we know that it is an outlier. So it just represents an unusual score in that class. Like I said, if this same person, if they would have been in class A, it wouldn't have been unusual. There were other people that did that too. Which class has a greater range in test scores? So the range, not the interquartile range, but the range. So if we look at class B, when we look at their range, we still have to count the outlier in that. So we're going to go from 52 to 88. That's the range of class B. However, class A goes from 50 to 90, so they have a bigger range. So it's class A regardless of how you look at it, but you do have to count the outlier when you're looking at the range. Okay, 34, it says the upper 25% of the students in class A scored above what? So you should be able to answer all of these questions based on what you see in the box and whisker plots. So maybe pause the video and then you can answer those and just come back and make sure you got it right. Okay, the upper 25% of students in class A scored above 78. The lower 50% of class A scored below 70. The middle 50% of class A scored between, so they scored between 65 and 78. Whenever you're asked between two numbers, always give the lower one first. Don't say between 78 and 65. That doesn't make any sense. The lower 75% of class A scored below. So 75% is going to be 3 sections of that box and whisker plot. They scored below 78. The upper 50% of class A scored above 70. So with a box and whisker plot, you ought to be able to answer all the questions like that. Okay, I'm just noticing I forgot to explain on 33, so hopefully you wrote something down. But class B, that was between 88 and 52, and that's less than 90 to 50. So that one's 40, and then that one is 36. So 36 is less than 40. Okay, back to the last question on this part. Which class performed better on the test? So if you're the teacher and you're trying to see which class did better, what are some things that you might think about? So one thing you might think about is like which class had the higher score. And so you see that class A had higher score. They had 90. Now, I don't know if that was one student or it might have been 4 or 5 students. We don't really have that information. Class B wasn't that far behind. They had 88, but still, if you're comparing those two things, then Class A is better. But what measurement that we have gives us a better picture of the class overall? Is it the high score? Is it the low score? So Class A also had the worst score. Even if you count the outlier, Class A did worse as far as the low score. So what are some things that would be a better picture of the overall class? So if you look at the median, that's probably the first thing that you might be drawn to, the 79 versus 70. If you compare those two things, Class B did a lot better. Another thing to notice about Class B is there wasn't as much variation. We didn't have scores all over the place as much as in Class A. So in Class A, you had like some kids going really low and some kids going really high. You didn't see that to the same extent in Class B. So you saw like some kids low, but like more of them were higher. So you had like the top half of the class in Class B was 79 to 88. The top half of the class in Class A was all the way down at 70 to 90. So you look at that and you look at this top half, they were all a lot closer in numbers. Like these guys are 20 between 70 and 90. Between 79 and 88, that was only 9 points. So that top 50% of the class, they did a lot more consistent work. And so if I was choosing which class is better, never mind the low score or the high score, because that could just be one person. That doesn't tell us anything. But if we compare the medians, and if we look at how widespread, either with the range or the interquartile range, Class B just looks better, more consistent. Okay, so I'd say Class B, and I would say that they had a higher median, and I would say they were more consistent. And I'm getting that from the range and the interquartile range. Okay, we're now going to go back to 27 and look at those questions, and I'm going to do that in the next video.